So in today's video, we are going to take a look at deriving the quadratic formula. This is purely an optional video if you're interested in learning about how we get the quadratic formula out of our standard form. The quadratic formula is used to solve for the zeros or the x-intercepts of a parabola, as shown here. And it's primarily used in standard form because it's the most difficult to calculate what our zeros are from the standard form without remembering other formulas. You're having to go through a bunch of steps or factoring it. So we have a quadratic formula as sort of a fail-safe option in the event that frequently what will happen is we're not able to actually factor it. And just memorizing the quadratic formula is usually going to be faster than completing the square every time, although that will work as well. So as I said, the quadratic formula is used to solve for the zeros of the function or the x-intercepts. And in particular, those are the points where y is equal to 0. So now we need to solve for x. And we need to get this so that it says x equals something. And then from there, we'll have solved for it. And the process I'm about to do, in theory, would actually work for any parabola. So if you replaced a, b, and c with actual numbers, this would work. But normally the way it works is we aren't going to do that for every parabola. We just memorize the quadratic formula and then apply it as needed. So I need to solve for x. And the first thing I'm going to do in order to solve for x is to get my x terms by themselves. So I'm going to start by subtracting c from both sides. So we now have that negative c is equal to ax squared plus bx. And then in order to make my life slightly easier, I'm going to have my quadratic lead with a coefficient of 1. So I'm going to get rid of this a here, and I'm going to divide a out. But when I divide a out, I have to divide everything by a. So I have to divide the bx by a, as well as the negative c on the left side of the equation. And when we do this, what happens is we now have negative c over a on our left side. Our ax squared has become simply x squared, and our bx is now b over a times x. Now, at this point, what we need to do is we actually have to complete the square. So we still have our negative c over a on this side, and we're going to rewrite this. So we're going to take x, and then we're going to add b over 2a, and we're going to square that. So this is the completed of the square, and this is how we go from having an x squared and an x term into only having a single x term, which allows us to solve this. But unfortunately, we have to actually complete the square because by converting this up here into this thing down here, we're actually introducing an extraneous element. And if we think about, by completing the square, what x times b over 2a times x times b over 2a is, well, x times x is x squared. X times b over 2a is going to be b over 2ax. X times b over 2a again here is going to be b over 2ax. And then b over 2a times b over 2a is b squared over 4a squared. And if we combine like terms, what this gives us is our x squared. And then b over 2a plus b over 2a actually gives us 2b over 2a, aka b over a. So that means that our middle term will be b over ax. And then finally, we add b squared divided by 4a squared. Now, if we compare this to what we had previously here, we have completed the square correctly because the first two terms match. The problem is this extra one. And this extra one, essentially speaking, is now trapped inside the parabola here, or inside the parentheses here. And we need to take it out since it's being added in here. So we then need to subtract b squared over 4a squared. And the reason for that is because inside the parentheses here, if we actually multiplied it out, we would have these two things plus this. And this is the thing we need to get rid of, so we're going to subtract it. All right, so from here, we're now pretty close, and we just need to go ahead and solve for x. So we're going to get the set of parentheses alone by adding b squared over 4a squared to both sides. And we're going to have to go down the page because this has so many steps. And now we have b squared over 4a squared minus c over a is equal to x plus b over 2a squared. Now, the one thing I'm going to do quickly here before we go ahead and directly solve for x is I want to combine these two fractions. And the way that I can do that is by multiplying c over a times 4a over 4a. And this is getting pretty cramped in here. Let me zoom in a little bit more so you can see that, hopefully a little bit more clearly. We're going to multiply the top and the bottom by 4a. In fact, let me make this even more clear by rewriting this step. So we're going to cross it out and rewrite it just so that it's totally obvious what's happening here. So we have c over a, and we're multiplying it by 4a over 4a. 4a over 4a, of course, is 1. And I can multiply anything by 1 without changing my equation. And this will allow us to combine our fractions because now we're going to have b squared over 4a squared minus 4ac over 4a squared is equal to x plus b over 2a squared still. And once we combine these together, we now have b squared minus 4ac over 4a squared is equal to x plus b over 2a in parentheses squared. And now we can finally get rid of this squared by taking the square root of both sides. So we take the square root here, we take the square root, whoops, I totally drew that into the previous line. And of course we have to add in our plus or minus because that's what happens. So we have plus or minus the square root of this whole thing. Although I'm going to do something a little bit peculiar here is I'm actually going to set each part of it, I'm going to make it into its own square root because that's one of the things I'm allowed to do with square roots. So we're going to say it's the square root of b squared minus 4ac divided by the square root of 4a squared. These two statements are equivalent to each other, so that's no problem. And what I'm allowed to do here is I'm allowed to actually take the square root of 4a squared because it's a perfect square. b squared minus 4ac we can't really do anything with, but I can do something with 4a squared. In particular, I can say, well, on the top, we still have our plus or minus b squared minus 4ac. But on the bottom, the square root of 4 is 2, and the square root of a squared is simply a, because a times a is a squared, 2 times 2 is 4. And we still have x plus b over 2a. Our final step is just to subtract b over 2a. And one thing you're going to notice immediately is that since these two fractions share the same denominator, we actually can combine them as we normally would. And that yields the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And that is the derivation of the quadratic formula. And we had to use a lot of the skills. It was entirely working with a literal equation. We had to divide some variables, subtract some stuff, combine fractions, and take the square root of both sides and complete the square. So definitely a culmination of a lot of the skills we've learned so far. And again, you don't have to worry about doing this every time. For some of you, it might be interesting to see where exactly this came from. And that was what I was aiming to provide in this video.